All right, I'm going to go over how to fill in that chart, basically how to find all of the information on these different, on a series and a parallel circuit. So if we go to for the resistance, we can put them in right away. I know that R1 is 220, R2 is 360, R3 is 750. And we also know that R total equals R1 plus R2 plus R3. So RT equals 220 plus 360 plus 750. So if I put that into my trusty calculator, then I get 220 plus 360 plus 750, and that gives me, right over here, 1330. All right. Now, we know our total voltage is 12 volts. Okay, so from that, we can find using V equals IR. I want to find my total resistance. So I total equals V total over R total, which is 12 volts over 1330 ohms. Oops. Equals 12 divided by 1330 gives me 0.0009 amps, which would be equal to, if I move it 3 places, will be 9 milliamps. So 0.009 amps, and all of these are going to be the same because in a series circuit, the current is the same amount of water in every one. So now I just need to find my other 3 voltages. So again, V equals IR. So V1 equals I1 R1. So that is 0.009 times 220. V2 is 0.009 times 360. And V3 equals 0.009 times 750. So 0.009 times that will give me, this one gives me, I'll put it over here, 1.98 volts. This will give me 3.24 volts. And the last one is 6.75. And if I add all of those up, I'm sorry, V1 should equal my V total. When I add them up, 1.98 plus 3.24 plus 6.75, I get 11.97 volts. Not bad. Okay? Then we have our parallel circuit. Okay? In a parallel circuit, we know that our total voltage is, again, 12 volts. And in a parallel circuit, the voltage is the same everywhere. So I know that this is 12 volts, this is 12 volts, this is 12 volts. And I know that my R1 is 330, R2 is 100, and R3 is 1.3K, so 1300. Okay, now to find my R total, so 1 over R total is 1, oops, I'm sorry. That would be 1 1 over R1 plus 1 over R2 plus 1 over R3. So R total equals 1 all over 1 over 330 plus 1 over 100 plus 1 over 1300. Okay? And I use that 1 over x button because I like the 1 over x. And where's my 1 over x on this one? There it is. Okay, so 330, 1 over x plus 100, 1 over x plus 1300, 1 over x, hit equals, and then I got a tiny little number, so I have to do 1 over x one more time. I get 72.5. Okay, is that right? Yes, it is. 72.5. So this is, it should always be less than the smallest one. So I know it's got to be less than 100. So that makes sense. Okay. Once I know that, then again, my I total is going to be my V total over R total. So that's 12 volts over 72.5 ohms. And I get 0.165. So I get 0.17 amps. So 0.17. So again, so now I need to find my individual currents. I1 is going to be V1 over R1, which is 12 volts over 330 ohms. And I'll just write here, I2 is going to be 12 volts over 100 ohms. And I3 is going to be 12 volts over 1300 ohms. Let me do those. 12 divided by 330. 0.036. Where am I? I should have gone, well, we'll see. And then 0.12. And 0. Okay, and again, I total should be I1 plus I2 plus I3. Whoops, 3. Let's see what we got here. Oh, I got to write these in here. Okay, so 0.36, 0.12, 0.009. And you'll see this is the biggest number because it's the smallest resistance. So it's the biggest pipe, lets the most electricity through. When I add them all up, oop, I added those wrong. Let me try that again. I get exactly that number. I get 0.165. I think I had 0.167 is what I rounded up. So not bad. Okay, so that's basically how to do it. One series, one parallel, and